How many have heard of the Monty Hall problem? There was a show on television predating Wheel of Fortune called Let's Make a Deal. And I don't remember enough about the show as to know whether this is exact, but it's been sort of modified over the years to be as follows. So it was the case that this was a show where there were 3 different doors, and there was a curtain in front of them, whatever. There was a prize behind one of them and not behind the other 2. And the contestant would, get to choose a door. So let's say they chose door number 2. And then as the story goes, Monty Hall, who was the host, knew where the prize was, obviously, and would open one of the other 2 doors that didn't have the prize behind it. So if you chose door 2 and the prize was behind door 3, Monty would open door 1, vice versa. And of course, if you chose the right door, then it wouldn't matter which of the other 2 doors he opened. Then, to add to your stress, if you're the person sort of guessing, after he opens one of the other doors, he gives you the option of switching. Okay, well, you chose door 2. Would you rather have door 3? And the question is it in your best interest on average to switch? How many think it is? How many think it isn't? Okay, about 50-50. So someone defend and how many think it's neutral? Someone defend an answer.
When you first choose, you have a 1 in 3 chance of answering correctly.
Okay.
Once he removes an option that you know now is incorrect, your odds increase if you choose 1 in 3.
Okay, so that's correct. You have a 1/3 chance of hitting it right the first time. So 1 out of 3 times if you play this game, you'll be right, and switching will be bad. The other 2/3 of the time, the host will show you what door it's behind. So 2/3 of the time you win by switching, 1/3 of the time you don't. Now what's interesting about this problem is how confusing it was for lots of people over the years. This came out in a column called Ask Marilyn, I don't know what, 15, 20 years ago. Parade magazine, I don't know if she still exists. And she didn't explain the problem very well, which led, I think, to confusion, but she got deluged with letters. Letters saying, this is a bunch of crap, etc., but some of them were from professors at universities who were mathematicians, and of course they caught the most attention, saying there's enough math illiteracy in this country that we don't need you contributing to it, and so on. And of course it turned out that she was right. I mean, she'd explained the answer correctly even if she didn't explain the problem in sufficient detail. But it's something that for some reason people see or they don't see. I've heard of a case where some high school student did this as a science fair project, quiz people and actually simulated it and so on. And the judge, and keep in mind the judges at science fair projects are pulled off of streets if they're sober, things like that. The judge is arguing with the kid. The kid has it right? And the judge is saying, no, you don't understand this, and so on. And I have a colleague that I argued this out with one time. I spent over an hour with this, and he wouldn't get it. And finally I said, okay, imagine there are 1,000 doors. The prize is behind one of them. You choose one. I'm going to open 998 other doors, and now I'm giving you the option of switching. And it's like, he then realized, okay, but then he said, I agree it works for 1,000 doors, but it doesn't work for 3 doors. So, I don't know what it is about that. Anyway, that's entertainment, nothing to do with class. As I told the class last hour, you are not the only ones bored in this classroom. So 2 quest things are up. Oh, by the way, office hours today, there's a little interval around 2 o'clock when I'm going to be gone. Probably 10 minutes before to 15 minutes after. Here's some produce thing that, you know, the pickup time is whatever, and I got to bike down to halfway down to downtown. There are 2 quest opportunities up, and I've just been told there's a problem with the bloody link that I put in there. This one, so I'm going to reload the article. I double checked this yesterday. It must be my browser is remembering the link. Anyway, don't try this until it goes to the right location. The other one is a survey. And there's some confusion about that that's showing up. So it's a personality survey, right? This is the link to the survey, but to use it, you need a user number, which is 3 digits, and then a 7-digit password, and you get those on Blackboard, and you go into Blackboard under grades, and the last thing you'll see is called survey, and you look at the comment field to get those. And I put this thing up like yesterday at about 4 o'clock, and by 7, 60 people had already done it. And okay, see me after class. Do you have a way to access Blackboard here? Your phone is fine. If we do it on here, the problem is it's all recorded, so I don't want that, you know, the whole class getting to watch you log in to Blackboard. Okay, but you don't go to Quest for this, right? I'm calling it a Quest thing. It counts as one of those, but you actually, the link is on our homepage. Yep.
I was trying to use the link this morning, it said page forbidden.
When did you, yeah, so I kill it during lecture for reasons that you can perhaps anticipate. So it'll go up shortly. It'll be up by about noon. Okay, 2 questions. Now, there's an article that one of you gave me, and actually a colleague sent it to me last night also, which I just killed the page that I wanted. Oh, and by the way, so one of you, Julia actually, came to me last time, we had an absolute hell of a time trying to get into MediaSite, did everything we could, called up ITS, still wasn't working, getting this error message, and then we actually took her computer up to the ITS help desk, and they said, oh, here's how you clear the cache, and once we did that, everything was fine. So for people that are getting, when you log into MediaSite, if you're not being directed immediately to that EID login page, there's something in your browser's memory that is bypassing it, and you've got to get that out of there for it to work. So last time I talked about repeatability in science in terms of, you know, there's how do we decide whether to accept or reject something? And there's a short-term process of statistics we use. Is a result statistically significant, etc. But there's this long-term rule of repeatability. If something fails to repeat over time, then we say it's no good. So it's now coming to light by sort of the highest levels of science in the world that a lot of what's being done in science, what's being published, is not repeatable. And that the problem is much bigger than anyone realized. Right, and so these are just some broad statistics, right? So the way science works, formal science works is, you know, people do studies, they publish them, and then we hope what gets published is right. A rule of thumb among biotechnology venture capitalists is that half of published research cannot be replicated. Half. And even that may be optimistic. Last year, researchers at one firm called Amgen found they could reproduce just 6 of 53 landmark studies in cancer research. That's pushing 10% success rate. A group at Bayer, which is a drug company, like Bayer aspirin, Bayer, managed to repeat just a quarter of 67 similarly important papers. In 2000, and so what difference does it make to you? Well, in 2000, so the decade from 2000 to 2010, they think 80,000 patients took part in clinical trials that were based on research that was later retracted, meaning it was found to be flawed in some fashion. So there is a significant cost here. And in terms of the cost, so the federal government sponsors a lot of research, meaning they pay for it. NIH is the big organization in this country, actually in the world, for biomedical research. Anyone guess as to what its annual budget is?
In the billions.
How much?
In the billions.
In the billions. Good. What? 30 billion, approximately. Right? So they fund a lot of research, and if half of it's bullshit, then it's saying we're wasting a lot of money. Now, something can be not repeatable for a variety of reasons. What do you think the reasons could be that underlie this? Bad protocols. So that's part of it. What's the most extreme reason, the most egregious reason something that's published is not right? You're sort of focused too much on the details of the last bunch of lectures. Just in terms of the big picture, what would you consider to be the biggest sin in science? Yes, fraud, fabrication, right? That accounts for some of it. But then there's a big gray area in terms of what goes on in science that has to do with what we might call bias. So there is, in science, recognition is everything. And you get credit for important discoveries and being the first to do them. Which means if someone's discovered something or published something saying we've discovered this, there's virtually zero incentive for you as a researcher to repeat that, right? If you say, okay, well, we're going to go look and see if that's right, you get zero credit for it. If you try and get money to repeat it, no one's going to fund your applications, right? I mean, the funding rate at NIH now is probably less than 10% overall, meaning for every 10 applications submitted, slightly less than one gets funded. You're competing for money, you're competing for reputation. Journals, high-profile journals, don't want to publish a second of something. So the whole process has a built-in bias in favor of publish the first study, publish the most exciting studies. Journals, journals are competing too, right? So the best thing, so the top journals in the world are called Science and Nature. I'm not going to hold you to this, right? And then there are a bunch of journals that are, a step down from those. Rejection rates at both of these are on the order of 90%, right? They have so many people submitting to them that, they can only publish 10%. And so they're going to choose the most exciting things that get sent to them. So there's a real strong incentive for researchers to overstate the importance of their results, maybe to cherry pick. Yeah?
Are you saying that a lot of this bad science is really reputable journals?
Oh, yeah.
Is it the whole point to be peer reviewed?
Oh, yeah, but peer review, so, I mean, when someone sends you a paper to review, and we get inundated with that stuff.
Well, but isn't the review supposed to be kind of blind to remove the bias? Because you're not supposed to be friends with the person who originally.
Yeah, but if you get a paper from some other group and you look at the results, you don't know what they've cherry-picked. So to publish a study, when you publish a study, you might be looking at 4 times the amount of work that you're going to put in the paper. It might even be a smaller percentage. You don't know what they've thrown out. You trust, you're not going to repeat these things in your own lab. You're going to assume that what they're publishing is correct. So peer review, there are some types of mistakes you can catch, but you're not going to catch a lot of them. And, you get tired of watching people hype things, overstating the significance of the results. But the journals, they want this. So even if you're a reviewer and you say, look, this is not very good, or they've overstated this, that's the last time you see the paper. And it'll go back, and the editors of the journal will make decisions about should we publish it, but the author ultimately gets to, kind of the final say in there. And these journals, especially at this level, are looking for articles that get picked up by the New York Times, by the London Times, and that, because they want the public to know about them. They want subscriptions. So there's this really strong bias in the process towards sensationalism. And what that means is you kind of look the other way on some things, you trust what researchers do, but it's at every level, from the researcher to the granting agency to the journals publishing things, and all of that's driving a tremendous bias in favor of things of, if you get a result and you believe in it, which, you got your own biases built in, you're not going to spend 2 years confirming the result before you publish it, because someone else might publish it first. So this whole process is kind of just being driven not in society's best interest. And everything you read about, what stuns me is you look at, you pick up things in the news. It's like, oh, such and such has discovered this new thing, and maybe it's going to lead to this. And, and now I'm old enough that I can look at that and I think, yeah, right, in a million years that'll happen. But everyone's pushing towards the same thing. The people writing the newspaper articles are trying to build their reputation. The scientists are trying to build theirs. The granting agencies are trying to get Congress to give them more money. And so everyone's pushing towards this particular goal, and that's probably a big part. Not fraud per se, but there's just all these biases built in that mean we're going to make a lot of, we're going to publish a lot of things that turn out not to be true. And maybe they were true under that one particular circumstance in the lab that got researched, but they're not true in general. Biology is pretty noisy. So anyway, that's something you got to be aware of. And we're in the last part of the course, we're going to come up against this with things like what I call conflict, where, company, what do you hear about, what are companies interested in doing that are marketing drugs, right? They want to get their new drug out there where they got the biggest profits coming in, and they're going to be overselling those as well. And you got to be aware of biases built into that process. So anyway, this article, as I say, one of you gave it to me, fits right into this theme, and it's a real problem right now. And the NIH is aware of this, and we're just becoming aware of it. We don't know what to do about it yet. Other than start paying, giving out grants for people to actually repeat important results, because there's otherwise absolutely no incentive. One thing I talked about the exam Friday a little bit, but it's come to my attention that actually some of this was a little maybe harder than I realized or involved more thought process. So what I want to do is talk about a couple of problems, just a couple on the exam, to give you an idea of the depth that was required. And then what I want you to do over this next section is to sort of come to me and say, if something isn't clear to you, say, I don't get this, right? And you don't have to do it in front of everyone. You can email me or you can come up after class, but I need to know what you don't understand to sort of be able to fix this problem. So this was on the exam, wasn't always the same number. And what I want to do is we'll just go through this and dissect it step by step as to how you deal with it. So clinical trial of a new drug is careful to ensure that neither its subjects nor its observers know which group a subject is assigned to. What does that tell you? Blind, double blind actually. So that rules out some types of what error? Bias. Okay, unknown to them, the first subjects to enroll were assigned to the treatment group until that group filled then the last subjects to enroll were all assigned to the control group. What is that a violation of? It's a violation of randomization. So it means it was not random, which allows what type of error to creep in? Bias. Okay, so remember there were two fixes for bias, blind and randomization. So this ruled out some types of bias, this not. So we're entertaining this as a possibility. Now, the study results indicated, and by the way, in this type of problem, right, where we're not talking about equipment spitting numbers back at you, or it's not specified, you wouldn't ever worry about RPA error. You're worrying about RPA error when you're getting individual numbers back that might be rounded. Okay, the study results indicated that the drug had a significant effect. What type of error is that ruling out? If there's a statistically significant result, it means sampling error is gone. So this is not sampling error. So you got those two ruled out. You got certainly something that can contribute to bias. If you were to argue human and technical error, there's nothing in the problem to lead you either way on that. So you're really left with, you got a very real problem with bias when you do a study that way. It's why we randomize things. So you got these different levels that almost every sentence is telling you something. It's not a giveaway question. You got to think it through. This one, God, I was so proud of this thing, and I figured everyone would just jump on this. So you're asked to determine the exact numbers, the number of copies of Time magazine in a container. I started out writing the problem with ball bearings in a container, and then, you know, my TAs and other people helping me said, there are going to be people that don't know what ball bearings are, so so I gave up. All copies are of the same issue and weigh the same. What does that tell you is likely to be absent? Sampling error. If everything weighs the same. So probably not sampling error, but you might get information later on that affects that. Your scale reads to the nearest pound. What is that a hint of? So, there are lots of you speaking, but it cautions you that maybe there's going to be something about RPA error here. After calibrating your scale with known weights of 0.1 and 1,000 pounds, what is that a hint that is absent? So this is a type of what? Standard, which is going to be nixing that for the most part. You first weigh the total contents of the container at 1351.8 pounds, right? You then separately weigh, that would have been nice to have that, 20 individual copies, which means you're not putting them all together, you're weighing each one at a time. Everything weighs 0.3 pounds. Now, given that your scale is accurate, precise, only to the nearest 0.1 pounds, what range of values is 0.3 consistent with? What true values, right? What weights for a magazine would give you 0.3? What's the lowest weight? Well, 0.35, just under 0.35, right? So because of rounding error, 0.3, you know, if your scale went to hundredths, this wouldn't be true, but if it's only to tenths, it can be anything down to 0.25 and up to 0.35. So immediately, what you should be doing is taking the total weight and dividing by these two extremes. And that tells you the bounds of rounding precision and accuracy error that could be affecting your total. And when you do that, it's huge. So I put this problem down because I thought you'd just look at this and think, oh, obviously. Had I known that it was as difficult as it turned out, I would have actually structured it into multiple questions to lead you through it. But unless I know what you don't know, unless you're saying to me, I don't get this step, I can't. I mean, it's a beautiful problem from my perspective, but I would have been happy to lead you through it.
Well, I thought it was like, since it's really significantly off, because one was 4506 and the other one was like 5,000. So I was thinking it's RPA because, not RPA, sorry, human and technical, because it's.
But someone do this calculation right now. Put your phones to good use as opposed to Facebook. Oops. So it's roughly 4 times this, right? Which is going to be almost 5,300.
That's 5,407.2.
Oh, 07. Okay, so right there, that's it. Your actual calculation here was 4506, right? But you know that with rounding precision and accuracy, you're well above 5,000. So the parameters given in the problem tell you that your actual calculations could have been anywhere from 5407, probably it would have been down to 3,900. Right? So no assumptions at all. This is the structure of the problem. And the moment you look at this, it's like, oh, well, of course it could be 5,000. So that's what I wanted you to do. But again, it's like I just blazed through it. I thought, well, it's obvious. And if someone would come to me saying, I don't understand this, it's like the M&M question on the problem, last year's problem. So if we can work together on this so you can, you don't have to embarrass yourself in front of anyone, but if you find, look, I don't think I really understand that, let me know, because I assure you, if you don't understand something, there's 100 other people in here that don't understand it too. So with that in mind, I will try and do a better job of structuring questions to leading you through things, because all of you could have figured that out, if we'd worked through something like that. Okay, so now we're going to the lecture, now that we're more than halfway through the class. So I do expect you to remember the discussion we had about repeatability. So I want to start with an observation. And the observation, for years I've used this as an example, and I found out this morning it's almost true. Red cars have higher accident rates, per car than do other colors of car. And we'll assume that this is a big enough sample that there's no sampling error. Now, when I looked it up this morning, there's a study in New Zealand, and it found that actually brown cars have higher accident rates. These are serious, where drivers were injured. And silver apparently is the least. So it's not far from the truth. What are some possible reasons for this?
Sports cars are normally red. People who buy sports cars want to show them off.
So finish the people.
And then they might drive more recklessly because they're concerned about other people watching them than watching their own.
Okay, so you actually, I'm going to dissect that. More dangerous types of cars tend to be red is one possibility, and the other is that more reckless drivers prefer red. Those are two different models that you covered. Other possibilities?
Younger drivers seem to be more attracted to red cars, and younger drivers have higher accident rates because they're more inexperienced.
Okay, so that would be a subset of this. Right, I mean, you're putting age into it, so it could be age, could be reckless for other reasons. Okay, so and we can clarify hard to see perhaps. Other possibilities? Well, we could keep going like this. It's the importance here is not these individual things, is that we can, so another one suggested last hour was red. Red inspires reckless driving. Reckless doesn't have a W in front of it, does it? A wreck does, but so I'm jumping the gun here. We're going to sort of ask a question that we're going to get to in a couple of lectures, but this is kind of motivation. So which of these models means that if you choose a red car over a different color of the same make, your accident rate will go up. So, will it go up here under this model? We're saying the same make of car, you're choosing red versus another color. Will it go up? How many say yes? How many say no? The no's have it with about a 5% turnout. More reckless drivers prefer red. Will your accident rate be affected by whether you buy a red car? I see some doubt here. How many say yes? How many say no? No, because your driving abilities are not being affected by whether you choose red or not, right? You're a particular type of driver, and so whether you get red or not doesn't matter to how many accidents you're going to have. Red is distracting. Will the accident rate go up if you buy a red car under this model? How many say yes? Okay. Will it go up under the red inspires reckless driving? How many say yes? How many say no? Okay. So what we're coming up against here is something called causation, correlation versus causation. This example involves a correlation. The correlation is cars of different colors have different accident rates. A correlation means that two things, which we will call variables, change or vary together on average. So as one variable changes, so does the other. So we're going to spend some time in here getting you to be able to recognize correlations. And I'm going to give you a list of things. You don't need to write them down in your notes. I'm just trying to emphasize that correlations are everywhere. So one that you're living with is there is a correlation between driver age and car accident rate, and driver gender and car accident rate. And those two are impacting what? How much you're paying for car insurance, or how much your parents are paying for your car insurance, right? So that means there's another correlation in there, which is between driver age, driver gender, and insurance rates, right? It's just an association. That once you know something about one variable, you know something about the other. There are correlations between age and all sorts of health problems. Which is why health insurance rates change with age. Life insurance rates change with age. Gender and height. Right? This is not to say that, all men are taller than all women. It's simply saying, on average, right, men are taller than women. It would also go with weight. Now that we're out of the 60s, we're back to there being a correlation between gender and hair length. But, family size and income, SAT scores, and university grades. There is no limit to where we find correlations. Here is a interesting one, if I can find the article again. Oh. Maybe I can't. Oh, there it is. This is a graph out of paper. It's a little more, about 15 years old now. Just want you to focus on the graph. The vertical axis is relative risk. This is the chance of dying in a particular period of time. 1 means you're at baseline for the population at average. The average, in the population. Someone tell me what this graph is showing. It is showing a correlation. They probably didn't emphasize this in high school. So you can pay attention to the curves. The curves are drawn, it's kind of best fit through the points. No. There's smokers are in there, but okay, well, I don't think we're there yet, but smokers are more likely to die. Okay, that's one thing that's shown. and ex-smokers are higher than non-smokers. But what I'm really wanting to pay attention to is the shapes of these curves. So far you're talking about the relative heights of the different curves. Focus on one curve. What is it showing? Yeah, but that's not the big point. Not the most exciting one from your perspective. Right, but she said that. Yes. Is that what you were going to say? So what's being shown here is that your relative risk of dying is lower with roughly this much alcohol consumption compared to none and compared to a lot. Now, right, you probably didn't learn this in high school, right? They probably didn't want you to know this. There are two bits of bad news from your perspective. First of all, the people in this study are my age, not your age. Second, this optimum here for survival is about 1 beer a day. So this moderate drinking is not 2 six-packs. Okay, this is a correlation. Someone give me a reason why the pattern might occur.
Stress affects our mortality, so if somebody has maybe just one beer, like one glass of wine, it reduces stress, so your mortality rate will go down. Then
Okay, so it's what you're proposing is that alcohol itself is causing the reduced mortality.
for the lower part. But
Right.
if you
Yeah, the moderate alcohol is causing the reduced mortality. Someone give me an explanation in which alcohol is not causing the mortality. Okay, so one model is drinking the alcohol up to this point. It actually benefits you in some fashion. The other is the class of people in this category are better adjusted socially, or maybe they're healthier than these, and so they can, they're out doing more social things than that. Okay? Dissecting these types of explanations, what causation means, what correlation means, is where we're going to starting next time.